Hello guys, welcome back to the show. Today I will be diving into type classes. I feel like most of the resources online make type classes way too complicated, so I will be explaining type classes using simple examples. If you want to learn about type classes, then I'm assuming you're already familiar with implicit and type parameters. So if you're a beginner and you would like to learn more about Scala, there are resources online, but most of the resources just make Scala way too complicated. A very useful resource that I found was this book, Programming Scala, which is really good. It is really good. So if you want to learn more about Scala, I've got a link in the description. You can check that book out. It's really good. And Essential Scala is really good as well. But I found Programming Scala really useful. Let's get back into type class. Before diving into type classes, I would like to go over implicit in Scala. So what do we even use implicit for? So implicit is basically you telling the compiler to do a little bit of work for you. So what do I mean by that? By allowing the Scala compiler to do some of the work for you. Just make a simple method over here called multiply. Okay. So I've got a multiply method. The multiply will take in first number, which is of type int. Okay, and then we've got a second number, uh, which is also of type int. Let's say it will return a string, and what we want to say is the first number times second number. Okay, so times this number over here. The second number is, then I'll provide first number times second number. So if I do run this method and I say multiply, then I provided the first number as 2, then I provided the second number as 3. All right. When I run it, I can say 2 times, it says 2 times 3 is 6. Okay. The purpose of the implicit in Scala is that I can define a value over here called random number, which is of type int, and I'll give it a number such as, let's say 3. Okay. So I want the compiler to pass this random number into this. Okay. So I'm telling the compiler that when I run, what I would like to do is I want to tell the compiler that when I run the multiply method, I want you to pass a value. Check the scope that I'm in. If you see a value called int, if I don't provide it, just pass any value which is int. Into this method, which is marked implicitly. Okay, so I can mark this as implicit. Okay, then I can mark this as implicit. Can get rid of this, and now when I run it, see the compiler passes the 3 into the multiply method, and then I can get, the result value. I can change this to 4, and the same thing happens. So what is happening behind the scene is that the compiler is passing this value, right? It's passing this value um, in here. So it's basically exactly as me saying 2 times 4, all right? But the compiler is doing this bit for me. It is putting the 4 in there for me. And then one thing you need to know about implicit is that there must only be one type for that scope. So for instance, if I had implicit val, let's say second random number, which is like 8, you can see that the compiler will complain, okay, that there are two implicit, there are two values which have been marked as implicit. So the compiler doesn't know which one to use. That's why you need to have just one type for that scope. Um, Implicit can be a bit, difficult to understand, but bear with me. That is what it does basically. It lets the compiler do some stuff for you that you don't have to do. Okay. Um, so that is implicit. Now we can go on. Let's get rid of this. Everything goes back to normal. Um, let's go back to traits. So if you're from an object-oriented programming background, right? It's like having a parent class, you extend, that parent class. So subtyping, polymorphism, and all that stuff. That's what trait allows you to do, all right? So if I have a trait human and I define inside of the human trait, I say human can say hello, okay? So I would like to say, okay, all humans can say hello, all right? So I would like to define a method inside of my in my human trait. It takes in the name, which will be a type string, and it will return a string. And I will say hello to the name. Now, if I have a class, okay, so class Chris, I'll call it Chris or class person, okay. Um, Person will take in a name. When you instantiate person, it will take in a name, or you can decide not to even give a person a name, right? And then person can say hello, okay? The person can extend the human trait, and then I can say define say hello, which will return a string as well. So I can say that. So let me change this name to hello, this method to hello. Then I can say hello. This hello method will take in a name, which is a string. Then I can say hello. And I can pass it the name. So if I create an instance of the person class, so I can say val person, uh, be a new person. I did not pass the person class anything. So I've created a new person. I can say person dot hello, okay? And I can pass it, let's say Chris, and then you can say hello Chris. All right. So that passing in Chris called the say hello method. All right. It called the say hello method inside of the human trait. Okay, the trait is the super type, right? And then the person class is extending from that super type. Um, just like in object-oriented programming, just like how they would do in object-oriented programming. That is the basics of implicits and traits. And then you've got like type parameters. Basically, a type parameter allows you to use a method or a trait for different type. Basically. Um, I don't want to get too much into details because we can talk about variance, being covariant, invariant, and all that stuff. But this is just the basic, just to let you understand type classes, which is the main focus of this video. But we can go on to define a method here called add. It will take a type that we haven't defined, we don't define initially, and it will take in something of that type, okay? And then let's say return a string, all right? So we can say that hello, this type hasn't been defined initially, so this can be any type. We just know that we want to return a string, but the method can take in any type. So I can just say, for instance, add um, and I can insert put in Chris again, and we'll say hello Chris. Okay, I can put in an int, you know, 6, and you say hello 6, basically. Um, so it helps us to use a method for different types. That's what the type parameter does. So now that we've gotten that out of the way, we can go on to explain what type classes are. Let me get rid of this. Imagine you had a library, right? Let's say final case class person, okay? Let's say it takes a name, it's a string, and it takes in an age, which is also a string, all right? And imagine you also have like a dog library, so final case class dog can provide it a name, which is a string. The best thing to do this will be to initially explain what type classes tries to solve so that we can appreciate what type classes actually does. So life without type classes, imagine we want to um, give some extra common functionality to person and dog. But imagine that we don't have access to the source code of person. We don't have access to the source code of dog. We would use something like the adapter pattern. So basically, what we would do is that imagine we wanted to add like a chat functionality to person or dog, all right? We would go with something like object person can chat, and then we would define a method chat which takes in something um, of type person. Let's put it for now that it will return a string, and we can say, hello, my name is the person's name. So let's call this person just so we know what we're talking about. We can say person.name. So we have a person, we have a person can chat object, and inside of the object we've got a chat method, okay? And we pass in something of that type person, which is the person type that we will pass in, and then we can use, we can call the method, or we can call in whatever method inside of that person that we would like. Um, and this pattern is called the adapter pattern. That's what we would do. And imagine we wanted to do the same thing for dog. We could say that object dog can chat. We could say define chat. It will take in dog of type dog, and then it will return a string. Okay. And then what it would say is that let's say woof. My name is. Let's get the dog name. The dog's name. So uh, dog dot name, and I can woof. Let's get the dog emoji because I love this stuff. So let's get the dog emoji right here. All right. So woof woof. My name is dog.name and I can woof. So basically, this is how we would implement this without type classes. But there is no way to specify that we have two different types which have something in common, which have like the chat method or the chat functionality in common. And it doesn't really look nice. And if you want to have other methods or implementation, we will have to do the same thing for that as well. Basically, it makes our code difficult to maintain. All right. We want to write code that is easy to maintain, easy to be extended, and easy to understand. So type classes helps us to resolve this issue, and it resolves this issue using the implicit method and using the type parameters that we saw at the beginning. Okay, so let's use type classes to resolve this issue. So we can define a trait again called cancha. Okay, so it takes in a type that we don't specify, and then it has a method in there called chat, which takes in something, and that something has to be of type A. All right. So we have a trait can chat. It takes in a type A, which we don't know at the beginning what the type is, and we have a method called chat, which takes in something of type A. It returns a string. Let's put that in here as well and make things really easy for ourselves. With type classes, you need the actual type class. So this is the actual type class. We need an instance of the type class. So we've got the type class, which is this trait, can chat, and the method that it has. That is the type class. Now we need to create an instance of that type class. Okay? How can we create the instance of that type class? We can say something like person can chat, okay, which extends that person can chat or extend this trait can chat of a certain type. We've created an object person can chat, which extend the can chat trait, and it takes in a type person. This can work, and we want to implement. You see how we got to that error? It says that we need to implement, we need to, because this is abstract, right? The chat we having, it doesn't have a body, basically. We need to implement the method. So we will say that define chat. The chat method takes in something. If you look at the signature of the method inside of the trait, the chat method takes in something of type A, all right? The type A is the person. So we can say that person is of type person and it will return a string. And we can say, hello, my name is person.name. This is what we have, or we can do the same thing for dog. So we can say that object, my name is, and I can provide it the dog.name. Okay, so I can say something like the dog.name. Okay, so it compiled. Now then we pass it that. Okay, and then when we run it, we have hello, my name is Chris. What we really want is to be able to use one chat method. We want to have something like a chat util, like a method that accepts things that can chat. Okay, so we can go on to create an object called chat util. Okay, so this chat util, it has a method in there called chat. This method will take in a type A, and then the type A will be, um, let's call this some type, and that type has to be of that type A, and then it will take in one of these, instances of the concat of the type class. So we can say that it will take in an instance of the type class, which has to be of type concat A, and then it returns, let me return a string. So we're saying that we've created a method, we've created an object called chatUtil. The chatUtil has got a method called chat. It takes in a type A as the type parameter, then it takes in some type of a type, and this type will be either person or dog, or it could be any type that you want. And then the second parameter that you pass to the chat method, right, is an instance of the type class. So it has to be of type can chat of A. And some of the instances of the type class we've seen is dog can chat and then person can chat. Okay, so we can now say that the instance of the type class dot now the instance of the type class, these instances, they all have the chat method over here. All right, so we can say, okay, chat, and then we can pass it the type that we want, some type. Okay, now let's go on and run this, and then you can see that everything works. And basically, this is basically what type class are. But we have one more step that we need to take before this becomes, it becomes like succinct. It becomes like, it becomes clear. It becomes beautiful. So right now, if we would like to call this chat method, we have to say chat util. We have to say something like chat util dot chat. Okay, we give it some type. The type that we want is the person type, which has a name and an age called, let's give it 9. Yeah, and then it takes in a second parameter. So person dot, we've got in the first parameter is this one, and the second one has to be an instance of the can chat type. So the instance of the can chat type is person can chat, right? So we can pass in person can chat right here. Now, when we run this, hello, my name is. name because that is the name that I've provided over here. Let me say Chris. Let's run it again and say, hello, my name is Chris. Yeah. Now, still, we are hard coding this right here. This is when the implicit value comes into place, the implicit that we saw earlier on. We would like to let the Scala compiler and do the work for us so that we don't even provide, we don't provide like the type class instance because there's no point providing the type class instance. We want our type to have a chat type. We want our type to be able to chat. We know that already. So why don't we, make the compiler just, just do magic and put in that instance for us. So what we can do is to make this implicit, right? Is to make this implicit. When we make it implicit, we can make that implicit as well, so that when you run it and you don't provide explicitly provide what type instance to use, what type class instance to use, the compiler will take this, all right, and then put this right in here for us. So I can get rid of this one and make this implicit. Okay, so I've made this implicit. I need to make this implicit. And now see everything works. So that is the basic definition of type classes in Scala. We can recap and just go back to everything that we talked about. Initially, we've got a type person, we've got a type dog. We created a type class. We wanted this person type and a dog type that we don't have. Imagine we don't said imagine initially that we don't have access to the code base or the source code of person. We don't have access to the source code of dog. We cannot modify those source code. So you create a type class, which will take a type. We create an instance of the type class, right, for the types that we want, with the methods that we want. And then we basically we created an object because we didn't want to explicitly pass in, the instance of the type class into the method all the time. We made them implicit so that, the compiler will basically do the work for us. We can do the same thing for this one as well. I can pass it the dog instance, dog type, a dog, let's call the dog Ben. Sorry if your name is Ben and you're watching. So if you call the dog Ben, so when we run it, woof woof, my name is Ben. So basically that is what type classes in Scala is in a nutshell. If you want to learn more about type classes, look in the description. I've got some useful resources that will help you understand type classes and some books that are really useful and that help me understand type classes as well. Thanks for watching and see you next time.